third day, second session. He completed his MTech in textile engineering from IIT Delhi with more than a decade of diversified experience in the field of textile. He is also a blend of educational institute, industry, as well as research. So he is the right candidate or speaker for the today's program. In-depth multidisciplinary textile research background is having in India and abroad also. He is having experience in quality management system, ISO, IEC 17025 and NABL accreditation. He is currently in Wellspoon India Limited, WAPI, from there he joined this company in 2018 and is currently working as deputy manager product development. He was for small span of I think less than 2 years in I think more than 2 years in the Mantra also, from 2016 to 2018, so close to 2 years. Then he's also went to Technical University of Liberec, Czech Republic, where he was there around 3 years and 3.5 years, working as research scholar and handled a good number, one of important project over there also, as development of self-reinforced polypropylene composites. He's also handled few projects in Mantra. Example, effect of structural parameters of fibers and fabric on properties of spoonless non-woven fabric, development of infrared emitting therapeutic fabric made from thermoreactive minerals, embedded PET filament yarn. In the currently the company where he's working in that, after COVID-19, successfully they have planned, initiated and trials the scale of antimicrobial and antiviral samples, and that is also within a 3 months. With this small intro, he is also a well-known researcher having good number of publications in national and international journals and conferences. So with this small introduction, I request Mr. Bele to take over for the today's lecture. Thank you, sir. Thank you very much. So you can share your screen also.
Visible also?
Yes, sir.
Okay, good morning
Hopefully all of you are able to see the screen of the speaker. It is shared with you, and he's going to talk on non-woven technology and sustainability. Sir, before starting, we are taking generally the poll for whether the voice of speaker is audible, presenter is audible or not. Okay. So can you say few 1 or 2 minutes your experiences in Czech Republic?
Hi, good morning all of you. Let me know if I am audible.
Yes, sir, you are perfectly audible.
Okay.
I request all please be fast, participate in the poll, so that we'll come to know that speaker's voice is audible or not. Remember, he's a renowned speaker, and it's definitely going to be very useful. His talk is going to be definitely useful. Second thing, be connected with this program and try to get as maximum as possible. I think 50% people are voted. 60% people are voted. Now within a 30 seconds, I am going to close it. Be fast. And check whether you are audible. If anybody feeling difficulty, then check your audio settings. Otherwise, leave the meeting and rejoin it back again. You check your network quality. Keep the good good microphone with you, headphone with you, and sit at the place where the network is very good. Please be fast and vote. Around 65% people voted. Remaining all within a 10 minutes, I'm going to 10 seconds. Within 10 seconds, I'm going to close the poll. Be fast. Be fast. If anybody is having difficulty in voting also, minimize the screen, again maximize it. Problem is going to be solved. So 96% says that it's audible. 4% those who are having problem, please rejoin the meeting if required. Otherwise, check your audio settings. And I think presenter's voice is perfectly okay. And I request Mr. Bele to start his presentation. Bele sir, please.
Good morning, all of you.
Yeah, good morning, sir.
First, I'm thankful to Mechanical Engineering Department of SVNIT and Mantra for inviting for a speaker. So instead of wasting time already, we are late to start. So I am going to present on non-woven technology and sustainability in textile industry. So first, go through what are the topics of my presentation. The first, we actually this presentation is divided into two parts. The first part is where we are going to discuss about non-wovens, and the second part we are going to discuss about sustainability in general. The first part we will go through brief introduction of what is meant by non-woven technology, what is non-woven, how it is used, then what is the difference between a conventional technology and the non-woven technology, then what are the various methods by which the fabrics are manufactured, where are its application. Also, the most important, it will be the current interdisciplinary research area we will discuss, where we need to have 2, 3, 4 disciplines working together on a major problem to solve a common goal. Then secondly, the second part of the lecture is divided into sustainability, where we will deliberate on what is the meaning of sustainability, what is the future impact, and what will be the approaches throughout the world, and how we can put a contribution to improve the overall goodness of our planet. So before moving to non-wovens, just have some brief introduction about some textile terms. Since many of the attendees will be from various departments, not 100% will be from textile, so I take liberty here to introduce some of the textile terms. Some of the terms may be aware, some may be new to you. So first, let's start with I hope everybody knows about fibers. Basically, at least some people must have heard what are the fibers. So here you can see there are, I have taken some examples. One is cotton fiber, another is polyester, another is polypropylene. There are so many of fibers, but I have taken here 3 fibers just to elaborate my point. Another same fiber, we are making yarn. In this particular slide, you can see first here cotton fiber, then cotton yarn, polyester fiber, polyester yarn, polypropylene fiber, and polypropylene yarn. See, no fiber is 100% exact. It depends on where you are going to use. When you are manufacturing clothes for apparel wear, then mostly cotton can be termed as the king of the fiber. But when you need particularly industry engineering fibers, or where we need more strength to materials, then polyester can be taken over, and some other various types of new fibers also developed that we are not going to deep detail. We will first know
Sir,
what are the basics.
sorry for disturb to you. Can you make a presentation mode, sir?
Presentation mode, okay.
जो अपना सर जो व्यू का जो परसेंटेज दिखाते हैं ना, उसके लेफ्ट साइड वाला जो सिंबल है ना वो।
Actually, one of my laptop key is not working for scrolling down. That's why I have
ऊपर
clicked
वाला, उसके ऊपर वाला जो आप, हाँ वही स्लाइड शो मोड में, या अच्छा इट इज नॉट, अच्छा हाँ वेरी गुड, यस सर थैंक यू।
Actually, one of my key is not working, so I have to always shift. While changing the slide, I will shift and then I will make a full screen.
Okay, okay, no problem, not an issue, sir.
So normal technology is having fiber, then fiber is converted to yarns, and then yarns are either woven or then knitted, or they are used for tufting or some stitch bonding. So basically, for next slide, we will have better idea. Here you can see these yarns are used. Actually, this slide is showing different fabric forming methods. The first one, Surat people are more familiar with, is weaving. So many shuttle loops are there. So here you can see the first picture. I'm pointing the cursor is normal weaving technology. Here the fabric is made on weaving, and the right hand side of the same image, it is the way the yarns are arranged to make a fabric. Normally, the vertical yarns are called as warp, and horizontal yarns are called as weft. So, combination of warp and weft, these are normally interlaced together to form the fabric. Normally, our t-shirt, normal shirts, trousers, most of the fabrics are woven on weaving looms, and they are called woven fabrics. Then there is another technology that called as knitting. Most people are aware, I think. Knitting, where you are taking needles. The picture is showing us a hand knitting, but there is machine knitting also. So just for example, I have shown this picture. So here the difference between weaving and knitting is the loops are it is formed through the loop. It is interlooping of yarn. The weaving was interlacement of in 90-degree angle, interlacement of yarn. In knitting also we can have weft knits, warp knits, depending on the direction in which the loop is progressing. Normally t-shirts, sports wears, where we need more flexibility, the fabric need more stretchability. These are this type of structures are used, knitted structure, mostly in t-shirts or sports wears. Then another fabric forming technology is braiding. This particular picture, so there are 12, 16 number of bobbins and all threads combined together to form a braid-like structure. Here you can see a braid-like structure. Also braided, they are normally used on narrow bits and for many industrial application, beltings and or other applications. So every particular technology is, the fabrics are made or the products are made according to end use of where it is required. So when we are needing a fabric which should have a higher strength, suppose a parachute fabric, so we should always select a technology which will provide us a higher tensile strength. Then going further, another technology is tufting. Here the yarns are tufted on a backing. It is called as primary backing. Mostly it is made from 100% polypropylene weaving. And then here is a tufting machine where needles tuft at various speeds from 300 rpm to 1000 rpm and create a tufted fabric shown in this particular diagram. You can see here there is a base, and above that base there are loops. And lastly, where we are more going to focus in this particular presentation is non-woven technology. In this non-woven, we can see non-woven mostly it's a very long line of machine, but objective of the most progressive objective of non-woven is they are mostly production speeds are very high and they are very cheap. this particular diagram, you can see the arrangement of non-woven fibers in particular way. So I am going to, after seeing this particular technologies, we will discuss about what is the difference between a normal fabric forming methods and non-wovens. Actually, non-wovens are engineered fabrics, and they are normally manufactured by keeping a particular application area in mind, and to fulfill the particular needs of the product in its use. By that property we are going to manufacture, we are going to select the properties which are most important, and they are normally prepared that way. So non-wovens are manufactured by high speed production. That I already told, the production speeds are high compared to weaving, compared to knitting, compared to other processes of fabric manufacturing. Also they are low cost. Mostly the fibers used in non-wovens are polypropylene, polyester. Mostly synthetic fibers are used. The major portion is synthetic fibers, and as PP is comparatively cheaper than other fibers. So at most of the time it is a low cost process. And here in this particular diagram you see what is non-woven. Basically non-woven is a combination, you can say textile, it is textile process. Then also the basic principle, some of the parts, some of the non-wovens which we will discuss further in our slide, they fall under this particular category. Paper technology, basic, some non-wovens are basic principle taken from paper technology, how they manufacture the paper. And plastic, because I already explained, mostly synthetic fibers, polymers are used. So it is a amalgamation of all three components, that is textile, paper and plastic. So here we are going to describe, actually there is so many definition of non-wovens, and always there is a confusion among the researcher, among the policymakers, what can be termed as non-wovens. So as far as I am concerned, I have read through, and I feel this is the most complete definition by ISO 9092. It is non-wovens are defined as manufactured sheet web or bat of direction fibers oriented fibers bonded by friction and or cohesion and or adhesion, excluding the papers which are woven, knitted, tufted and stitch knitted. There is a bonding yarns and filament weight milling whether not additionally required. So basically difference between previously the non-wovens were defined as those which are not woven. Now this terminology is not good, because those not woven means knitted can be considered as non-woven, because these are not woven. So this definition has broadly defined the products which are either manufactured in sheet form, wave or batter direction where the fibers are oriented, bonded by friction or cohesion, and products which are not woven, knitted, tufted or stitch bonded, and normally made with a natural or man-made staple or continuous filament in situ format, or maybe in form in situ. So before actually proceeding with what are the various methods of non-woven fabric formation, first we will go through application of non-wovens. I think after the emergence of this COVID, everybody is wearing mask. The face mask or the protective mask we are using, they are of non-woven fabrics. So first application here discussed is disposable nappies. Baby diapers, here in this picture you can see baby diapers are a combination of various types of non-woven use, because in baby nappies we know the most important application is absorbency of fluid. Fluid absorbency is the most important parameter. So here the non-woven fabrics are engineered in such a way that they will have highest absorbency in nappies. Other various products are used also to increase the absorbency among them, but mostly nappies are developed through non-woven fabrics. Also same with sanitary napkins and tampons, which are used for female hygiene. Their properties should be also same. They should be having high absorbency. So here also non-wovens along with other absorptive components they are used. Also, there are sterile wraps, caps, gown, masks, and curtains. These are used in medical textiles. The medical textiles also having a large proportion of non-woven fabrics. Also, when you are developing non-woven for medical textiles, the most important properties are barrier properties, either in terms of breathability or either in terms of the blood penetration, because mostly when during a surgery or in a surgery room there are cutting artery veins and sudden splash of blood may happen. So to avoid infections, to protect doctors, and these kinds of barrier properties are must. So when the fabrics are engineered or fabrics are developed, the engineering point of view will be to improve the barrier properties. Another example of non-wovens is household and personal wipes. So when we are developing wipes, there are two types of broadly two types of wipes: dry wipes and then wet wipes. So wet wipes definitely they must have a better absorbency, and the dry wipes the most important property, they should be crash resistant, because mostly dry wipes we are using for our LCDs or laptops screens to clean the screen. So they must have a smoother surface which will not provide scratches to the surface. So that this is how the fabrics are engineered. Then laundry aids, there are also fabric dryer sheets they are using. Then apparel interlinings, in various apparels the interlining, mostly interlining fabrics they are using non-wovens. Then carpeting and upholstery fabrics, padding and backing. In carpets also many types of non-woven are used. Mostly felt or spun-bond non-wovens are used. Either they are used in two types. When it is used as a primary backing, means threads will be tufted directly on that backing. So that particular backing must have better shrinkage properties. So non-wovens made in for this particular application, the first property they should pass, they should have a shrinkage control. Normally it is around less than 3% shrinkage is allowed in tolerance. Then wall coverings, various types of wall coverings non-wovens are used. Then agriculture coverings and seed trips. Then automotive headliners and upholstery. If you have observed various automotive components, headliners, if you, there are failed or spun bonded non-SOR are used. Mostly it is a layer of non-wovens. It is a combination of 2-3 types of non-wovens combined together, joined together to provide sufficient thickness, sufficient acoustic properties, sufficient bounciness, resiliency. Then non-wovens are also used in filters. Just for example, it is used in various types of industrial filters, but in our day-to-day use, we are using water filters. In water filters, normally after certain time we replace the candles, the filter candles. The filter candles are mostly the melt-blown type of non-wovens, which are known for their very fine structure of filament, which provide good filtration properties. If you observe the candles, you can see it is a type of non fabric. Then it is also nowadays it is used for envelopes, then tags, various types of labels in insulation. If you see construction work going on, paintings or some other type of construction building works, it is also used as house wraps. Also for roofing products, non-wovens are used, and obviously very old application of non-wovens is civil engineering fabrics are the fabrics used in geotextiles. Various in type construction, road construction, various types of geotextiles are used. Geotextiles may be a combination of non-wovens and other textiles to provide the stability to road surface. So these are overall application, and also there must be some application left where various types of application are there. This is a general idea. Before understanding non-wovens, what is the method, what is the types of non-woven, how it is manufactured, just to have an idea where are non-wovens are used. So you can see there are n number of application, and in future also various types of fabrics or various types of technical industrial products are going to be replaced by non-wovens. It is a exponentially growing field. Okay, moving further. So before manufacturing any product, the most important part is what are the raw materials? What are the raw materials used? So basically, non-ons are all are. That is the beauty of non-ons. Just I forgot to mention. If you consider weaving woven fabric is made from, first the fiber is converted into yarn, then yarn is converted into fabric on loom. In case of knitting also, fiber is converted into yarn, then yarn is converted into again a knitted product. In other application also, in tufting also, fiber is converted yarn to then into a tufted product. So every fabric forming method, there is an intermediate and processes to convert the fiber to the final product. But in case of non-woven, that is the beauty, or that is the most objective or the advantage of non-woven is the fibers are directly converted to a final product. मतलब in a single line, in a single manufacturing line, the feed is fiber and the end product is the final fabric. So that is the advantage of non. Various types of raw materials are used, various types of fibers are used. I already explained most of the synthetic fiber. The dominant non-woven market share is captured by polypropylene, polyester, and viscose, mostly synthetic fibers. If you see here, the polypropylene is having it is that is the again why polypropylene is used. Two factors: one is lightweight, very low density, and another is cheap. It is, the cost is very low as compared to all other fibers. The cheapest fiber is here is polypropylene, and the properties, its inert nature is also having advantages while we are engineering a product. Other component is polyester fiber, vastly used in various applications. It is also finding very innovative applications in non-woven also. So basically, when we are selecting a fiber, most important properties again they depend on what are the type of what is the application, final end product application of non. Suppose we are taking a fiber for a baby diaper or female hygiene products, sanitary pads. So polypropylene will not be useful. Why? Because polypropylene will not absorb moisture. So in that case, we need a fiber which absorb moisture, or sometimes a synthetic layer can be used. A synthetic layer where the fibers are having higher strength, so they can support the other thick cushion or thick products used in particular product. So they can be used, but they are used mostly as a support, not the primary function. So primary function in non-wovens depends on the end use application. So accordingly, the fibers are selected. Okay, now we will start. What is the material flow? How the non-wovens material process flow? So our raw material fiber, the first you can see here, it is fiber preparation process. So here they have the general classification is divided into two. Here we can say a dry laying or wet laying technology. So here in this particular left hand side column, the initial starting point is fiber, where we are first preparing the fiber, then we are forming the web. A web can be formed by two methods, either is a dry laying method or a wet laying method. Then if you see on the right hand side, it is polymer preparation. Here we are going to talk about spun bond type of non-wovens and melt blown type of non-wovens. So in next subsequent slide, we will have better information about what is meant by spun bond, what is meant by melt blown, and how they are made. Also, after this is only one basic difference is web formation process. In non-wovens, the most important classification we can say it is how they are classified in terms of their web formation process. After web formation, all our application can be same or can be modified into. So after once the web is formed, the web needs to be consolidated. The webs needs to be provided at strength. So there are various bonding methods are used. Either the webs can be bonded with mechanical type of bonding, or they can be bonded with some chemicals, some glues, or they can be thermally bonded. So bonding type depends again the type of end application we are looking for and which type of bonding we can, where we need more strength, or finally the stiffness or the product must be flexible. So accordingly, the bonding is selected, and once the bonding is selected, finally it is a finishing process. Finishing, either providing a value addition to a product, or some embossing, or some designs, chemical finishing or mechanical finishing. So this is overall the material flow. So we will start one by one. First, we will start with where there is a fiber is ready and we are using directly in dry. So here it is a air laying process. It is a old process. Actually, normally this requirement started. If you see the webs from oven materials or oven fabrics, basically the yarns are converted. When we are converting a web, particularly a carded web, the carded web, there is the fibers are oriented in one direction, and when fibers are oriented in one direction, their properties will be different in their transfer direction and parallel direction, because since the orientation is one direction, so mostly the strength in will be in that particular direction. So to avoid that particular phenomena in textile is called as anisotropy of the web, meaning the fiber properties, if tested, the web properties tested in transfer direction or in longitudinal direction, the properties will differ. So to compensate that, the researchers in particularly 14, they tried to prepare a web which will be having homogeneous properties in both directions. So 100% homogeneity cannot be achieved since it's the random nature of fiber to orient. In this technology, you can see the waves, the feed rate feeding is here. Maybe feeder, then this roller particularly is taking fiber, and then there is a stream of fibers forced to a jet to air on a particular conveyor belt. Here it is a random arrangement of fibers. It can be in mostly longitudinal direction, and some of the parts goes in transfer direction. So at least as compared to a carded web, this particular web will have more homogeneous properties in both directions. So these types are non-wovens, where the fiber is directly laid into with the help of air on a conveyor belt, and then it is formed into web and then consolidated to form a final non-woven. It is called as air laying. Same structure, but here instead of air laying, the fibers are laid in form of slurry. Actually, this is somewhat similar to paper forming technology. In paper forming technology, we normally use the wood pulp. Wood pulp is used, and wood pulp is dissolved into a suspension. Emulsion is made where we are having a more than 70% of pulp is used. Then it is called normally a paper. So there is some wetlet technology where we are using less than 70%. We are using a fiber suspension. The liquid is drained out, and the final conveyor belt. You can see here the fibers from the slurry are formed onto a screen, and then this particular wet web is consolidated to form a non-woven. Again, this wetlet type of non-wovens, they find their applications in battery separator and in some another applications also. The overall the contribution, if market share is considered, air laid and wet laid normals is less as compared to the next technology we are going to discuss. It is spun-bond technology. Mostly in Surat area, or overall, if consider in India, there are various n number of plants which are developing through non-woven fabric to a spun-bond technology. If you see here, spun-bond technology, it is a normally thermoplastic fibers are used in polymer form, and the polymer is extruded. Just if you say the synthetic fiber, normally synthetic fibers are developed by taking a polymer resin, and then resin is then extruded, melted, and then extruded to extruder, and the fibers are formed through a spinneret. So more kind of similar machinery structure or machinery setup is there. But based here the fibers are formed are 50 in between 50 to 35 micrometer in diameters. If you see here, it is extruder. Here the polymer is fed, and then it is extruded through this spinneret. Here is a quenching chamber to solidify the filament. Then it is attenuated, and it is finally uh, forced onto a conveyor belt. Here it is consolidated, and then it is transferred to a compaction roll through compaction roll and calendary roller. Finally, it is a wound. Spunbond type of non they are normally used for durable and disposable application. What kind of? The main application for spunbond application are in automobiles, civil engineering, hygiene. I already told spunbond. Most of the time they are having less absorbency, but they can be used as a support layer to increase the stability of the structure. In medical, in packaging, in agriculture also. In agriculture, if you see the most of the time the plants in nurseries, the plants are covered, or the particular shade, they are shaded with various types of non-wovens in various color, normally green. So this is the mostly used technology nowadays, spunbond technology. There are some limitations also, but before going to limitation, we will see the next kind of technology. Here it is a picture industrial machinery setup. You can see here it is a conveyor belt, and as described in earlier diagram, here the fibers are getting are this is the final output of the fiber. That is the melt spun or the extruded fibers are directly coming onto a conveyor belt. The conveyor belt is moving, and here after this the film will consolidate or form. Now, after considering spunbond technology, again it is another technology is melt blown. As I described earlier, the water filter side gave the example of candles used in our regular home appliances water filters. They are mostly melt blown. So if you see spunbond the diameter is around 15 to 35 micrometers. In melt blown, that is the peculiarity of this particular technology is we can have a mesh or a web of fiber which are very extremely fine, 1 to 5 micrometers. So this particular mesh will act as a better filter for high-end applications. So owing to the smaller fibers and larger surface area, that is of in textiles or in generalized general engineering, if you are making fiber more fine, the surface area will increase, and more surface area will lead to better filtration properties, good barrier properties, and also good wicking properties. So overall, melt blowns are used. Majority of the component is filtration. Then another is insulation, and again liquid absorption. See, more finer fibers, then again more finer capillarity. Number of capillary forms, and more number of capillaries means they will increase the liquid absorption. Just I will show you example of melt blown. Basic principle of melt blown technology. Here it is an extruder. Again, extruder. If you are aware, we have already discussed. The synthetic fibers are normally manufactured by this particular route, where chips are extruded at a temperature around, for polyester it is around 280 to 90 degree, and then they are forced through a gear from to continuous throughput rate, and through die it is showing the fibers are jetted with a high force on a collector. Again here the uh, fiber fineness, or what we can say fiber how fine are the fibers, it again depend on the distance between this die and collector. We cannot increase more. There must be optimum setting for this particular distance, but mostly to once the fibers are extruded, the thickness of the film or the thickness of the web plus the fineness of the fibers can be controlled with this collector and this distance. So basic difference between spun bond and melt blown. The melt blown technology requires polymer with considerably low melt viscosity. That is the major difference between the two. See, we are already manufacturing very fine fibers with melt blown. So obviously, to extrude very fine fiber, the melt must have very low melt flow index or low melt viscosity. Also, the initial investment in spun bond technology is higher as compared to melt blown technology, but the melt blown products are higher. The prices of melt blown products are higher because we are using a compressed hot air to throw or to jet the fibers on a collector. That's why normally melt blown are costlier than the spun bond. Spun bond are the cheapest non-ones available as of. So this is another method. Now we will move to another technology. It is a spunless technology, or it is also called as hydro-entangled non-woves. If I observed, see, these types of non-woves are basic property is high absorbency. So mostly in diapers, mostly in wipes, these types of non-woves are used. If you see face wipes, various face wipes are available in products Johnson and Johnson and all others. Basically, they are formed through this technology, spunless technology. Here I will explain briefly what is this technology, how it is. This is a very raw schematic how the process flow. This is raw cotton. Here raw cotton is fed, raw cotton is formed with this arrangement of cylinder liquid in a wave, a carded wave, thin wave, and this thin wave is passed through a high pressure stream of jet, a high pressure stream of water. That's why it is also called as hydroentangled. See, up to this point, the wave form do not have any mechanical strength. If you take a wave, it have very less tearing strength or no strength almost. But when these fibers, to improve the strength of this product to wind or to use in final application, the product must have has strength. To increase the strength or to impart the strength, the products are the web is consolidated, or the fibers are entangled with the help of high pressure jets. And once the fibers are entangled, or the the wave is compacted, then it is passed through a dryer, and then it is formed into a roll form. Before finishing, it is not fully line setup. It is a brief idea. It is shown here to give a brief idea. Raw cotton converted into a wave, thin fiber wave, and then it is compacted with the help of jets, entangled hydro water jets at high pressure. A more technical diagram is here. This is the passage of the wave. The fibers are passed on a cylinder, a vacuum, and inside there is a vacuum to compact the wave. And this is the high-speed water curtain. The water is forced at a high pressure, and the water jets act as the mechanism to bond the fibers. Once the fibers are entangled, there is a strength to the wave. So, moving to next type of non-ovens, it is needle punch non-ovens. Here on needle punch non-ovens, the basic is same. Here the wave is formed, and the wave is compacted with the help of needles. So if we compare the previous technology mentioned, that is the spunless or hydro-entangled technology, and when we compare the technology with needle punch non-ovens, basic mechanism is different. That is, the entanglement of fiber in spunless was carried out with the help of water jets, and here we are carrying it out with the help of needles. So this we can call it is a bonding through mechanical means. Needle punch non-ovens are mostly the high. They are thick or they are bad form. They are normally used as felts in various applications, particularly for cushioning or acoustic applications. or where we are need more resiliency. So this kind of products. In carpets also, these types of felts, needle felts are used to provide secondary backing to the carpets. Then somewhat interesting, this is more general about non-woven. There are some innovation, though these are not new, but now many commercial products are available through these innovations. So bi-component non-wovens. So when we say bi-component, obviously the word itself suggests bi-components means two or more component, two or more component, bi-component. So when we say polyester fiber, as in the introductory slide we showed different types of fiber. When we say polyester fibers, that is made from a single type of polymer or single type of what we can say a resin or basic raw component is single and it is extruded. But in bi-component, same we can use two types of polymers, two different types of polymer to have a different function, to achieve a different function. Suppose we need a fiber which should have a higher strength and it should if you are using a fiber which should have higher strength also, and on the surface it should melt also to have a bonding, self bonding effect. Then we need a fiber where the fiber core is particularly one material, and then the top of the it's another material. So that is also a requirement. So when we say bi-component, the bi-component is mostly we are looking at three aspects. So in bi-component work, we look at polymers in different way, and basically it is combination of one polymer, more than two polymers to make a fiber. But why to make a different type of fiber? To provide something different, something unique to particular, in terms of either in terms of cost, either in terms of processability, or either in terms of functionality. So whenever we are developing a new product through this route, we are focusing mostly on these particular 3 points, either cost or processability or functionality. Just moving further, I will show you some images of the cross section of bi-component fibers. So this is most popular, that is two side. Here you can see the cross section. This is a single fiber, and this is a cross section of single fiber. So this is, if you see, there is separation between two. This is another polymer. This is another polymer. Okay. So we can call it as side by side bi-component. So one side will be a different polymer, another side will be a different polymer. Also in this also we can use another structure where it is called a sheath and core. Means the center will be a different polymer, that is core, and the sheath will be a different polymer to provide a desired function. Then here another, it is a segment, pi segment type of cross section. You can see observe here, this white portion is a one polymer, and this brownish or reddish portion what we are observing is another type of polymer. So these types of structures are used mostly in filtration properties. If you see, this is a single fiber, and when we are applying more jet or more air pressure, or when we are dissolving this one component, either depending on which component is dissolvable. So when we are dissolving one component, we will be having 1, 2, 3, 4, 5, 6, 7, 8 fibers. So this one fiber is broken into 8 number of fibers, which is very fine fibers. So these types of non-wovens or these types of bi-component fibers are used in filtration area of filtration properties, where filtration properties are required. Now this particular diagram shows same bi-component side by side bi-component fibers, but in a trilobal cross section. Here the cross section of the fiber is circular. Here the cross section of fiber is trilobal. This particular diagram here shows the mix of cross section. So some fibers are trilobal, some fibers are circular. So this overall, these are the bi-component fibers, and how they are made, that is very again unique. As I explained earlier, normally the polymers are extruded through extruder. Then there is a pump, and then there is a spin pipe which force the filament or the liquid through a spin pipe, which forms a final product, either in terms of yarn or in terms of wave. Here is the polymer A. the polymer A is extruded through this extruder, and the polymer B is extruded through this extruder. Here both polymer combines, and the final output is wave with a bicomponent fibers. And finally, these are basic technology, that is either the wave is compacted and then finally wound onto a roller for further processing or further application. So basic principle in bicomponent is we are using two extruders for two polymers, and finally they combine to form a bicomponent fiber, bicomponent wave, bicomponent non. So this is a more important slide as far as this particular lecture is concerned. As I have been informed, this is an interdisciplinary faculty development program. Faculties from civil, maybe mechanical or other disciplines are there. So as of now, previously the world is changing so fast. More types of interdisciplinary research are required. As far as non-wovens are concerned, I have just highlighted few areas where people from civils, people from mechanical departments, people from biotechnology, people from depending on the particular project application, various 3-4 areas people can work together to form a final solution. One example here, these are few examples. There are n number of actually projects or a number of research area people are working on currently. So biaxial spin pack design for controlled meltdown. So as I explained earlier, when we are using a melt-blown technology also, mostly the fiber orientation is in one direction, or mostly most fibers are oriented in one direction. So we are the challenge here is to develop a spin pack in extrusion where it will impart biaxial property to the weight. So that is the area where the other expertise needed. Then investigating polymer interface and its investigating polymer interface and its influence in thermoplastic bicomponent structure for non-woven composites. Here, mostly when we are using bicomponent structure, we are focusing on three types of polymer which are used for particular application. So this particular non-woven or this particular wave is going to be attached or with some particular product. So to have a better interface property, there is need, because when I am using PP bicomponent polyester and PP bicomponent fiber, the PP on the core will melt, but when I'm bonding with it with another layer of polyester, then there are problems of interface. The bonding will not be good. So this area needs to be explored. Then next is super hydrophilic and super hydroleophobic membranes for oil and water separation. So this is also one area. Nowadays, if you heard news, there are always oil spills. The tanker explodes, or there are some accidents happen in ocean, and it is dangerous to aquatic life also. So there are mostly these problems are there. So when we are considering super hydrophilic or super hydrophobic membrane, so it will be hydrophilic also, and it will be oleophilic also. So it will help to have oil water separation. Currently, many researchers worldwide, as well as in IIT Delhi also, they are working to develop this kind of products. So this particular field requires expertise from other departments also. And then this new phenomena, that is the graphene, for using the graphene oxides in development of conductive composite. Conductive composites also a new, comparatively new area. So here use of graphene. So there are some hazards are there. To have a safe, we can use this graphene in developing new conductive composites. So these are some examples where people can from various fields can come and they work collaboratively to develop new products for the betterment of overall industry, betterment of the society, betterment of the product, planet. So that is the requirement as of now. So we are coming to the end of the non-on part of my presentation, and basically when we are elaborating on what is meant by non-ons, and they are the first in definition I have explained. Non-ons are the engineered fabrics, so they are engineered keeping a particular end use application in mind, and accordingly the raw materials are selected, accordingly the method of manufacturing is selected, accordingly they are experimental carried out. So when developing any new product, since currently I work with product development department, so this is our how to guide. Actually, when we are developing any products, there are some factors we have to keep in mind. The first basic is materials and material characterization. Every process or every product there is some raw material. So basic, what is the raw material, what to use, and how to analyze. Because if you are not able to analyze, it is very difficult to maintain the reproducibility in production. So both factors are important. What you are using, which type of fiber you are using, and how to analyze the required properties. Then suppose particularly this is focused on non-ons, that's why we are focusing on this point: polymer processing and extrusion. So how to make particular which type of technology, which type of polymer extrusion, either should we go for spun bond, should we go for melt blown, what is the end use application. So how to make, or we should directly take fibers. We can take synthetic fibers in cut form. We can also use synthetic fibers, no need to melt. Take staple fibers, take synthetic staple fibers and use for making of non-on. Then engineer structure, this is what to make. So what is the structure? In the structure, what we need, final application. If we need strength, if we need absorbency, if we need porosity, if we need sound application, sound absorption property. So this is how we are going to engineer structure. Suppose we are needing acoustic property. So definitely the acoustic non-on should be having a high loft. The thickness must be more, which is directly proportional to the sound absorption. Also the particular non-on must have more porosity, more tortuosity of the fibers to have more sound absorption. So this is how the fabric are engineered. Then as far as this is practical part, then there is theoretical modeling also, micro and macro modeling, where we are going to analyze or study the structure and property process modeling. What are the parameters we are processing, what are the process parameters, and what are the properties we are getting. So we have to model this particular to have a quick trial, because in industry you cannot wait for 1 year, 2 years to develop a product. You have to very fast. So sometimes we have to analyze, okay, this is my property, this is my process, this is my final application. I need this particular count, this particular denier, this particular GSM. So I need to play with 1 or 2 parameters, and on this base I have to decide, okay, that will be my final output. So this is how we are going to do structure and property process modeling. And then the grand challenges. After this overall, okay, 4 points are covered. We are sure what to use, how to analyze, how to make, what to make, and the structure property relationships. Okay, we have studied what should be the input parameter to find the output parameter. The final outcome should be the grand challenges. That is what is the outcome of health, if it is safe or if it is sustainable. So nowadays, this, since we are moving in 21st century, and day by day the greenhouse emissions are basically we are climate change phenomena is going on. So that's where we need to focus, or we need to ensure the products we are making, they are sustainable. So now we are moving to our next part of presentation, that is sustainability. So this is this particular part I will focus on sustainability and innovations. So basically, what is sustainability? There are various definitions of sustainability, but basic overall the crux of the message is same. Sustainability is defined as how biological system endure and remain diverse and productive. Okay. And sustainability goes beyond these narrow parameters. Today, it refers to the need to develop the sustainable model necessary for both human race and the planet Earth to survive. Now, why I like this definition? Because here in this definition, they are always calling both human race and planet. Basically, most of the time, the climate change talks either in news or in digital media, print media, what they are always save the planet, save the planet. Basically, it's a sweet quoted language, save the planet. Basically, save the human race. That's why the planet saving is important. So basically, where talking about human race also, we are talking about planet also, because planet is safe, we are safe. That's logical. Now, sustainability, there are three pillars of sustainability. Whenever we are talking about making a product sustainable, or making a process sustainable, or making an organization sustainable, or making an individual sustainable, basically this can be classified broadly into these particular three terms. When we are talking about sustainability, either we are talking as a whole, we have to talk all three, but when we are considering, we have to consider economic factors also. When we are talking about economic sustainability, means what are the opportunities for growth. Also, suppose I am developing a product and it is not economically viable. Economically, it is not viable. So, shall I continue with this product? It will not be a practical situation. Though sustainable products are normally, as on today, sustainable products mostly, as far as textile field is concerned, and as far as I am aware, they are mostly, as compared to regular product, they are costly. Maybe 10%, 20%, depending on the product, they are costly. So we have to consider, while making a sustainable product or organization, economic factors need to consider. There are also green jobs and eradication of employment. So if we are making a sustainable business model, we have to also consider the social factors also. It's not if some technology is very highly sustainable, but ultimately it is causing the distress in the society, poverty in the society, and there are chances people are getting exploited, then also it is not sustainable. So the sustainability has both economic components, then social components, and obviously the major chunk of the sustainability is environmental factors. Basically, that is the first factor when we consider sustainable, because this trend, it is a global trend currently already started. That is many major retailers, IKEA, Walmart, or this kind of major, they are looking for products which are sustainable, or they are made from recyclable material to have to increase their branding, to improve, to gain the trust of their customers, and finally to save the planet. So why we are talking sustainability, because currently there is this, if you heard, every country has to control its carbon footprint. So there is a controversial debate going on currently on global stage. The carbon footprint must be controlled, and every country has to sign a particular treaty to ensure the carbon footprints. So basically, what is carbon footprint? As a whole, it is the sum of how the greenhouse emission gases, either they are released by as an organization, or they are either released or either they are through the individual actions. So basically, a more technical definition of carbon footprint is a total set of greenhouse gas emissions caused directly or indirectly by an organization, by an individual, event, or product. Just here, where I have taken the definition, there is example. The carbon footprint, or the amount of greenhouse gases generated when we fly from London to New York, is around more than half a ton of carbon dioxide. And we all know carbon dioxide is the, if we look at around our history, 5,000, more than 5,000, 10,000 years, coming from the biological cycle of the planet, the amount of CO2 is currently continuously increasing, causing the global warming. So when we are talking about the sustainability and carbon footprint, what are the challenges? Actually, when we are ensuring the products must be sustainable, the products must have less carbon footprint. But what are the opportunities for various people, the companies involved, what people involved, or what are the barriers? First, we will discuss what are the barriers. Normally, as I explained earlier, many major retailers, many major brands are asking for recycled products, or the products which are sustainable. Their theme of branding the product is sustainability. So they are branding their product, but people, and also branding, they are gaining the customer trust. That is, we are making products from a sustainable supply chain, sustainable recyclable products. Then also there another opportunity is to link the business to social and environmental projects, and also awareing the customer by involving them into sustainability initiatives. The third is technological innovation in production process, along with the supply chain, which contributes. Here the example is the polyester. If you have heard the mineral water bottles we are using, the PET bottles. The PET bottles can be recycled into clothes. So that is also new, because if PET bottles remain, if they are kept as it is, they will fill more land mass. In bigger cities, there is a concern going on, that is huge landfills are created in major cities or in small urban cities also. So these landfills also create a problem to them. So same bottles can be recycled and the same can be used for clothes. So that is also huge saving in terms of environment, in terms of sustainability, in terms of recyclability. But among these opportunities, major barriers are the most important barrier is thus traceability. How you can trace the material it is from recyclable source. Suppose I am going to use, I am going to prepare a product from a recyclable polyester. So I must have, to claim globally that this is recycled product, I must show the traceability, and that is the major concern, because in recycling, the various types of waste are collected, and to have their source of origin or to locate the traceability is very difficult. So that is a current issue or global issue to trace the recyclability or traceability. Then it is also the social and environmentally friendly textile might result in more expensive finished product. As already explained, if I compare the normal polyester, normal regular polyester product, and if I compare recycled polyester product, the recycle as of now, as of in my field, recycled products are costlier as compared to regular product. So that is also, you have to keep customer in mind also. If customer, we are okay for sustainability, customer must also be able to pay. So that is also one barrier. Customer mindset needs to be changed. And also, apart from cost, there is also perception in customer that is sustainable garments are not stylish, are not fashionable, or the appearance of clothing is not prominent, or it is not attractive. So that is also perception. In most of the time it is true, some, because recycled material, there must be some mechanical properties, may not be the same as of virgin material, but the perception needs to be changed. So these are the major barriers when we say we need to focus on sustainability. Now, as far as textile industry is concerned, every action or every steps in textile focuses on different aspects of sustainability. When we are considering production, including water and energy consumption, if you reduce water consumption, you reduce energy consumption, definitely it is going to save, either in terms of cost, in terms of social factors, in terms of environment factors. Again, when developing products, then again you have to be sure about the availability of the sustainable raw material, because one time supply will not continue. You have reproducibility in the production, so orders will not be verified. The effects of waste productions, the social responsibility of companies towards the employees and the surrounding planet. So all these factors need to be considered, or they are normally, most of the textile industry now, they are started to focus to have various brands or various certifications, because in various certification you need to have these particular aspects included in your management, in your organization, to have the certifications. Use of chemicals, include dyes and coatings. Health risk, also this is social factor again. Then again it is animal welfare. If you know the textile fiber wool, it is coming from ships. So how the wool is procured, how it is the ships are raised, how they are. So animal welfare also comes under that sphere. Again, social spheres of the sustainability. So currently, since we are innovating various products as a in product development department, we are always focusing on sustainable innovation. Not 100% our products are sustainable innovation, but 30%, 40% we are focusing on to make products which are sustainable. So when we mean sustainable products, we are mostly, apart from the supply chain and all other things, we are mostly focused on what is the type of material used, and most it is what is the difficulty of recycling in R&D? It is not optimizing about the resource consumption, but also clean tech product, because more number of product is, suppose a single product you are using 4 number of components, and if you are going to recycle that, more number of products or more number of components, the recyclability will be difficult. As far as carpet or this products are concerned, in carpets we are using primary backing, secondary backing, and the tuft or the pile fibers, pile yarns. So here we are having only 2 components extra that has to be recycled, but still it's a challenge, because the addition is such that if you are going to recycle, it is very difficult. Even the recycle process will cost more than the actual production cost. So that is also a major hindrance. Also, the sustainable innovation, new innovation application of textile. The textile can find application in solar collectors, pollutant filters, and insulation materials. These are the areas where there is a scope for innovation, particularly in terms of sustainability. Just finally, before concluding, there are 2 examples. Just I want to focus. There are many examples. Many organizations or many people are working. The first major global organization is Unify. It is a company which uses manufacture polyester recycled chips or polyester recycled fibers. As I explained earlier, these are taken from the water bottles, the PET bottles. They are using the used PET bottles, and they are finally making the chips or fibers. They are called as recycled polyester, or in technical terms, they are called as RPET, recycled polyesters. Also, the Austrian company Lenzing is also developed a new fiber based on cotton waste. So again, it is again, and very big brands, Zara and other these brands are they are using this particular products. There are again more examples. I have just shortlisted 2. So before concluding, okay. So the summary of this presentation, if I have to conclude shortly, first we will conclude about non-woven. Non-woven technology is a growing technology. As far as new products are concerned, there is vast scope for interdisciplinary research in new areas, new products. Many products can be replaced by non-wovens, but record must be engineered, and they must be having a sustainable supply chain. That are the important areas. And as I discussed earlier, key research area, multiple fields, multiple people from multiple experts from other fields need to come and develop sustainable products. That can be a major takeaway from this particular first half of the presentation. And the second half is self-explanatory. Everybody has to need to aware every action we take, finally it has an impact on planet, though negligible, but small steps cause a big impact. So every our action or whatever the organization we are working, or whatever the field we are working, we must thrive, because that is the future. In next 50 or 60 years, the sustainability is going to take all over, because there is no other option left. That going to be compulsory. Today we can say it's optional, but finally it is going to be compulsory. Okay, thanks.
Thank you very much, sir.
Thank you, sir.
Sir, Bele sir.
Yes, sir.
Hello. Yeah, you have given very wonderful talk, and there is going to be a very good response from the participant also. They are saying that your presentation is very good, Manisha Tandon. Excellent slide preparation and explanation. Taruna Jain says quite informative session, learned few new concepts, interesting session. Then Mithu Kumar is also saying that the concepts are explained very nicely. Anil Patel says that explanation is very good. So most of the participants got good insight from your lecture, sir. Naresh Kumar is asking one question. Can jute fiber be used for non-woven manufacturing for some specific application?
Jute can be used because it is used in geotextiles, jute can be used because see, jute fiber is having a high stiffness. It is very brittle fiber, brittle and stiffness fiber. So there are some limitations, particularly used in other applications, but can be used in geotextiles.
As a non-woven fiber.
Hello, sir?
Hello, can it be used for non-woven application?
Sir, in geotextile, non-woven sheets can be formed.
Okay, okay. In geotextile, it is finding the applications. Hopefully, Naresh Kumar's question is clear. We have a marathon sessions today, 4 lectures. So we'll shorten our question answer session. Thank you very much, sir. I request if Mati sir is available. Dr. Shaman.
Yes, sir. Yes, sir.
Yeah, can you give concluding remark within 2 minutes? Because now it is
yes,
12:30 and our speakers are very wonderful.
Yeah. What I say in one word, already some of the participants and you have already said that this 2 session means 2 part already very much well explained in terms of non-woven technology. He has given each and every details of each and every type of non-woven produced and what are the techniques available, what are the advanced technique available. Everything has been explained, and as well as what are the thrust area where we can put our more efforts to get something new things. So that also has been explained. And in the part 2 session, he has given example as well as what not only theoretical background as well as what are the companies are actually working on that and what are the product available. So everything has been well stated and well explained. So thank you, Bele sir, for giving such wonderful lecture. Thank you once again, Bade sir.
Yeah, Bele sir, thank you very much being a part of this faculty development program as a resource person. And with this, I end this particular session. Next session is going to be 2 o'clock. So please join at 1:50 sharp. This is going to be a wonderful session. I think, Maiti sir,
yes, sir.
There is small changes in this.
No changes in this session. This will be green technology in textile processing industry by Mr. M.G. Parikh. The next session, what is a virtual visit of testing laboratory? So that is interchange with electrical energy management. So that will be there today.
Yeah.
Electrical
Tomorrow's
energy management.
Energy management session is going to be the last session today, 4 o'clock. So don't miss that session, which is going to be very, very important. Small change is going to only be 4 o'clock session. 2 o'clock session is going to be as it is. And we have very experienced person for that, Mr. M.G. Parikh, who is having more than 40 years of experience at Manmade Textile Research Association, Surat. Be there at 1:50 sharp. Okay, sir. Thank you very much. Dr. Vivek, if you have anything to say, otherwise we can close the session.
Thank you, Bele sir, for your valuable time.
Okay.
Okay, so I think we can stop this session so that we can rejoin at 1:50. Thank you to all.